Hello, dear students. Let us study the orientation factors. All collision of the reactant species with energy more than or equal to threshold energy are not converted to products. This collision must have proper orientation. Let us understand with example about the orientation. See, you have carbon monoxide. It reacts with 1 by 2 O2 to give carbon dioxide. So we can represent it as carbon monoxide, that is CO, and O atoms are bonded to give you O2, and then you have CO2, that is, you know, C one side O, another side O. We know that CO2 is a linear molecule. Now this is your carbon monoxide. This oxygen molecule can come from any side, from any orientation, and collide with CO. But as we know that, and give us the product CO2. As we know that CO2 is in this form, you can see here, that is C one side O, another side O. It is not this form C, both the O are on the same side. So when this O collide at this point or at this point or at this point, this collision will not be fruitful. They will not give us the desired product C and O both the side. But if they come and collide from this side, there are possibility that they can be converted into the products. My dear students, I am telling you very clearly that there are possibilities. Again, we cannot say surely that when they'll collide, they'll give surely the products. But there are possibility that when they come from this side, and if they have their energy more than the threshold energy, they may be converted to products. So here, by looking at this, we can say that the cross marks are the improper orientation because CO2 is of this shape, not of this shape, and the correct mark are the proper orientation, which may be converted into products if energy is more than the threshold energy. So now we understand that reactant species having energy more than threshold energy, more than or equal to threshold energy, and if they have the proper orientation for collision, the collision may be converted to product. In other case, with energy less than or improper orientation, collision is not effective and will not be fruitful. So now we'll understand the effective collision or fruitful collision. This is the another term, or this is the another point of the collision theory. The collision in which reactant species collide with sufficient kinetic energy, called threshold energy, and proper orientation, so as to facilitate breaking of old bond between the reactant species and facilitate formation of new bonds to give products, are such collision are called effective collision. So my dear students, this is how we understand the effective collision. Let us try to understand the proper orientation with some one more example to explain the orientation factor. You know the reaction CH3Br plus OH minus, it gives us CH3OH and Br minus. This is your CH3Br. Now OH minus is going to attack, so OH minus can attack from this side, can attack from this side, can attack from this side. But as we know that these collision are never going to be fruitful, so no product is formed. This is because the orientation of collision of OH to CH3Br is not correct, is improper orientation. Now just have a look to this, that this OH minus collide from the opposite side of Br. When this OH minus collide from the opposite side of Br, the OH makes bond with carbon, and the bond between carbon and Br are broken. So old bonds are broken, new bonds are formed, and this is what it is formed, which is known as the intermediate. Sometimes it is also known as the activated complex. And from this intermediate, the new bonds which are formed become more and more strong, and ultimately they lead to a complete bond. And these old bond which are broken, they are completely broken, and we get Br minus as a product. So we get methanol as a product and Br minus nucleophile as a removed. So due to